Hello, I'm JW. This is continuing a series on the Brown Book, BS7671 18th edition, Amendment 2, and that was published at the end of March 2022. So if you're watching this years in the future, of course, these may be out of date, but certainly it's not out of date at the moment. It's all brand new. Now, this time we're going to have a look at Part 8. Now, Part 8 is 100% brand new. It was not included in any previous version, so nothing to compare it with previously. In terms of the content, it's not as new as it might appear because it actually comes from another standard, so we'll just have a quick look at where that actually came from to start with. But Part 8 is basically about prosumers electrical installations, and these are the things where you have, say, a typical house, which of course obviously uses power and energy from the supply grid, but it can also have things like solar panels for generation, batteries for local storage, and of course it can also put energy back into the grid from both of those, or maybe just one of those. So that's primarily what Part 8 is about. Unfortunately, we've only got some of what should be in Part 8, because as we'll see shortly, we've actually got the middle bit and not the bit before, and not the bit after either. So let's just get the book open and see what it is we've actually got. Now this is Part 8, and Part 8 did not exist previously. BS7671 only went up to Part 7. And Part 8 is entitled Functional Requirements, and there's the contents there. There's only a single chapter, which is chapter 82. Now, if you're wondering where 81 went to, then the answer is it wasn't included for whatever reasons. There is also an 83, which could have been included, but again, that wasn't included here either. Now, Part 8 in itself isn't actually new because it's been taken from another standard, which is where most of BS7671 comes from, and that standard is IEC 60364, in this case 60364-8. Now, we don't have a copy of that here because it's very expensive to buy, like most of these things are, but we can see what the contents of it would actually be. And we can see here on the IEC website that if we just do a search for 60364-8, you can see down here there's various things which cover. And the one we've got in BS7671 is basically the middle one here, which is -8-2, hence it's chapter 82, and that's the prosumers low voltage electrical installations, and that's what we've got. Now, the ones we didn't get is 8-1, which would be Part 8.1 or Chapter 81, Functional Aspects, Energy Efficiency. That was put in a draft some years back, but never actually made it into the final version. And then, for some reason, we don't have 8.3 either, which will be a Chapter 83, which is Operation of Prosumers Electrical Installations. Why that hasn't been included is a mystery, because ultimately we've got the bit about how to install and design them, but we don't have the bit about how to operate them. So yeah, we're not really too sure about that. So of the three, we've got number 2. But yeah, this is where you can actually get this information from. It's not some kind of secret mystery. It's all fairly readily available. And if we actually have a look on, say, 8-2 there, see, this has actually been around since 2018, so some number of years back there. And it basically describes what we've got as we've already got in this particular standard. If we go back there, we could have had a look at the functional aspects, which is energy efficiency. And again, there's not particularly new either. That's been around since 2019. 150 pages of it. And you can obviously buy these for rather large sums of money, as it says there. But you can actually have a look at the preview. So if you look at table of contents there, that says this is a preview freely available. You can then just scroll down and see pretty much what's in it and what we could have got and what we may end up getting in, say, the 19th edition or something else. So information's out there if you want to look for it and find it. Just a question of looking in the appropriate places. However, we're looking at what we've got at the moment rather than what we may get. So Part 8 here, and so this is all completely new. So we've got scope, the interaction of the smart grid and the prosumers electrical installation, PEI being prosumers electrical installation, the concept of it, the types, electrical energy management system, and technical issues. And then there's 4 annexes, A, B, C, and D. Those are informative, so not part of the actual standard. And that just gives you some additional information about various parts of it. Now, we're not going to go through the entirety of this, just some of the main concepts, but basically, we've got Chapter 82, Prosumers Low Voltage Electrical Installations, and the purpose of this is to provide additional requirements, measures and recommendations for the design, erection and verification of all types of low voltage electrical installation according to Chapter 11 including local production and or storage of energy, in order to achieve compatibility with the existing and future ways to deliver electrical energy to currently using equipment or to the public network by means of local sources. Such electrical installations are designated as prosumers electrical installations. Now, essentially what this is, and what this is talking about, is a system where you're going to have, say, a typical house, which in the past would have just had a connection to the grid. Energy comes in from the grid, it gets used in the house, and that's pretty much it. So that's pretty much like the old ways are best kind of scenario. But fairly obviously that's not the case in a lot of properties anymore, and sort of moving into the future it's going to be far less likely, because we've already got things like solar panels on the roof. They've been a thing for, say, 10 years plus, certainly in domestics. Relatively common to see those. And of course those are actually generating electricity in the property itself. That electricity can either be used in the property, or in a lot of cases it will end up being shoved back into the grid, sort of back where it in the opposite direction to the old conventional energy delivery. So that's already existing. Additional things you're going to have are storage within the property. Typically this could be, say, battery storage, so solar panels on the roof, charge up batteries in your house, and then you can use those batteries in your house to run your house in the evening when it's not sunny. And potentially you could also charge them from the grid at some point when the electricity was cheap, and then use them to run your house when electricity was more expensive. And of course you can also charge them from the actual solar panels. You can also charge them from wind turbines and all kinds of other stuff like this. So all of this stuff of equipment is going to mean that the flow of energy isn't just coming into your property anymore. It can come into your property, it can be stored in the property, it can then go back out of the property, and of course you can use it from the storage and from the grid and from your solar panels, theoretically all at the same time. And Chapter 82 really is covering the various terms and concepts of that. Now, I might think this is a bit out of date because these things already exist. This is not some new future thing that's going to be introduced in a few years' time. All of this equipment already exists and has done for years. Lots of people actually already have this installed in their homes and other buildings. Now, so we're not going to go through the entirety of this chapter because that would also be rather lengthy, but the basic concept is that a PEI is a prosumer's electrical installation, and the word prosumer comes from two words sort of gouged together, which is producer and consumer. So you're producing energy and consuming it, stick them together, yet prosumer. And electrical installation, obviously we already know what that is. And a prosumer electrical installation is a set of electrical equipment that has the following functions: supply, connection to public power supply, generator, PV systems, wind turbine and batteries; distribution, consumption, which is your standard loads that you're going to have in any property; and energy management, load shedding equipment and a monitoring device. Now, load shedding is another concept which fits in with all of this, and this is where, if you're connected to the grid is not some kind of infinite power source, despite what some people might think. And if it got to the stage where there was a shortage of generation, in order to avoid the grid shutting down and bad things happening, load shedding can be used, which basically means that certain things in your house could be turned off for a short time, say half an hour or something, if there was an excess of demand on the grid. And that's a way to reduce the demand on the grid and avoid it tripping out and basically going off. Now, what sort of things could you turn off in your house? Well, the idea is that this all happens automatically, so you don't have to actually do anything yourself, because of course it wouldn't work if it was going to be manual. Typical things might be, say, refrigeration, fridges and freezers, because fridges and freezers do use a moderate amount of energy, but if you're turning them off, say for half an hour, nothing bad is going to happen, because your freezer doesn't defrost instantly it's turned off. It still stays frozen in many cases for hours and hours and hours. So one possible scenario here is if there was a problem on the grid, say a major wind turbine or something went offline for some reason due to a fault, suddenly you've got shortage generation. So to counteract that, you need to reduce the amount people are using, and an easy way to do that is just send out a signal via some method so that all of these smart fridges that people have in their homes could be turned off, say for 20 minutes. Now, nothing in the fridge is going to go off, nothing's going to melt, because 20 minutes, let's face it, it's going to stay cold the time. But if you turned off, say, 500,000 fridges, that's going to reduce the load on the grid dramatically, and therefore avoid having to literally turn off whole towns or cities. And of course that's what would happen at the moment. If there was a massive shortage generation, London might be turned off, and obviously that's not a good scenario. But turning off, say, people's fridges and things could be a valid option to go for there. And the other big thing here is electric vehicles. So if you've got your electric car, charging up there. That again is a very large load. That can be used in one of two ways. One is the way we just described, so if there's a problem with the grid, there's not a lot of availability or a big drop in generation, turning off people's electric chargers for 20 minutes or half an hour or even an hour, that's going to provide a massive reduction in the load. So again, keeps things running for everything else. It's not going to make a huge difference to people charging their car. Yeah, it's not going to be charged up quite so quickly, but again, not charging it for half an hour, so what? It'll continue charging afterwards. And then the other way around is even more interesting, in that if there was an excess of generation on the grid, say it was the middle of the summer, it was really windy, and there was lots of sun shining, and all the solar panels were roaring power into the grid, but of course people aren't necessarily using lots of energy at that time. What could be done, rather than what happens at the moment, which is basically turning off things like wind generation, whatever else, so that it doesn't actually put the power in, what you could do is say, well, we've got all this excess generation, so send out a signal in the system to say that people should start charging their cars right now. And that could add literally gigawatts of load onto the system to use that excess wind energy and the excess solar power and whatever else excesses we've got. And again, you could pay people to do this, say, have some bonus, or say electricity is only 5 pence a unit this hour rather than next hour. So there's lots of these things which can happen. A lot of these things are sort of almost there, and in some cases are being trialled out and available in certain sort of limited ways. So it's all about controlling the grid and what loads are connected to it in a kind of smart way, so these things are all communicating together, rather than what we've got in the past, which is literally a big old power station, some wires and distribution, and then here's your house, which just takes whatever it needs whenever it needs it. So moving towards a more smart and intelligent kind of grid is really the aims of this. There's three types of prosumer electrical installation. We've got individual, collective and shared. I'll have a look at those in a moment. And they can also operate in different modes. Three of those. We've got direct feeding mode, reverse feeding mode and island mode. Now the modes are pretty easy to understand. They are covered in the various annexes there, which you can look at separately. We're not going to cover those here. But direct feeding mode is essentially what everyone's doing at the moment. You've got power coming from the grid, going into your house or business or whatever else, so that's pretty much what everyone's doing at the moment. Reverse feeding mode is the opposite of that. So you've got energy from your installation going back out into the grid, and this is what commonly happens with domestics where they've got solar panels on the roof. So in the middle of the day, 3 kilowatts or something coming off of that. Most of that is going to get shoved back into the grid, because most domestic properties simply don't use that amount of power during the day. And then island mode, which is kind of a new one. If the grid goes away for some reason, or you choose to be disconnected from it, you can continue running your property from your own independent storage. So this will be where you have battery storage in your house or your business or whatever else. The grid goes away either because it's too expensive to use or there's some fault or whatever else. You can continue running all the stuff in your house from your own batteries, and in that mode you're completely disconnected from the rest of the grid, hence in island mode it's a completely separate and self-contained system then. Now the three types of installation, got some little diagrams here, we'll just have a quick look at here. Individual, this is pretty easy to understand, it's just an individual property, so it could be a house or whatever else here. Got a connection to the public network there, as in number one, as in the grid connection, and then within the property we've got power supplies, loads and storage. And we've certainly got at least one of the power supply and the storage. Loads is just going to be your normal stuff in your house, like your washing machine and all the other stuff you've got plugged in. Power supplies will be things like your solar panels, most commonly, possibly wind turbine type stuff if you've got those. And then storage, most likely going to be batteries. So again, you can charge up your batteries from your solar panels, use those to run the loads in your house, possibly shove something back out to the grid if necessary, and even disconnect from the grid and run the whole lot separately from the grid as its own self-contained island mode. And the other two is collective. This is where you have a set of properties. Got your grid connection there again at the left, and you've got your loads, of course, in the individual buildings there. We've got 3 shown in that particular diagram. And then your power supplies and storage are actually in a separate area there, and there's only one set of those for that whole group of consumers. So this might be a block of flats, for example. So there's 3 in the building, they've got a set of solar panels on the roof, and they've got some batteries stuck down in the basement. Those solar panels and batteries are for the benefit of everybody who lives there, so all 3 properties. So though there's only one set of them, it can benefit and supply all of the loads in the 3 separate dwellings. And then the third one is shared. This is similar to the collective one. The difference here is that you've got your 3 units as shown there, but it could be any number really, anything from 2 upwards. The difference here is that you've got multiple units of storage. So in the case here, 3 of them have got batteries in them, and we've also got 3 sets of generation as well, or basically power supplies, so 3 sets of solar panels, for example. But although they're separate within each individual building, each one can share what it's got with the others. Hence the name shared. So in 7.1 there on the left there, if their batteries are full and then someone in 7.2 need a load of extra energy, those batteries could then be used to supply some additional power to 7.2 or 7.3. So it's just sharing, and the power can then be distributed along those things as and when necessary. There are various varieties of how this can be done and exactly where the grid connection is and how it's all managed, but those are the basic concepts there. Individual ones, where it's just your own building. Shared here, you've got various units with various things in, or the collective one, which is just a single set of storage and supplies, which can then benefit, say, a whole set of people, such as a block of flats. Now, an important part of this is the Electrical Energy Management System, or EEMS. This shall monitor and control the operation of all the power supplies, the load of the storage units, and the operation of load. So, in other words, it's controlling the whole system. There are a lot of ways that this can be done. There's a whole load of different things done here, which we're not going to go into in any particular detail. But essentially, this is going to be some kind of equipment which monitors things coming in from the grid, monitors your batteries, monitors your solar panels, and monitors the loads. And it's going to switch things on and off, say with your loads and whatever, and divert the actual power to wherever it's most appropriate to go. So if it was a very sunny day and your batteries were not charged, then it might be an idea for charging those batteries from the solar panels so you could use them later on in the evening when it wasn't sunny. Or if the batteries were charged and it was very sunny, lots of electricity coming in from the panels, and your electric car was plugged in, then it might be an idea to use that to charge your car rather than just flinging the electricity back into the grid and basically giving it away for free. Likewise, if the grid went off, this equipment would be the one which would decide, well, the grid's gone away, so we can switch into island mode, and then we can obviously run the house separately and keep things operating. So it's essentially a piece of equipment, or it could be multiple pieces of equipment, which just decide where to put the actual electricity when it's either available from panels, from the grid, or batteries, or whatever else, and use it in the most appropriate and suitable method. And again, these things already exist. You're not going to go in the shops and ask for an EEMS, so don't even bother that. But these sort of things do already exist. Some of the vehicle charging equipment, things like maybe the Zappi, for example, that has a lot of this functionality built in, because if you've got solar panels on your roof and you have one of their vehicle supply equipment, or chargers as they're slightly wrongly called, what will happen is that if it's set up correctly, if the sun is shining and you're generating electricity from solar panels, it will put that amount of power into your electric car, therefore making the best use of that, and it will adjust and do that all automatically for you. And you can also connect to things like batteries and other things as well. So this equipment does exist, it's already being used. This is just really catching up and saying, oh, actually, we should really put it in BS7671 because these things are already in operation. Now, there are a variety of other things to consider with this, and we're not going to cover these in detail here because that could be a whole series of videos on its own. But one very important thing about prosumer electrical installations is to consider methods of protection. So, for example, protection against overcurrent. Now, of course, you obviously need this because all installations will require that. However, in a PEI, as it says here, overload and short circuit currents shall be determined at every point of the PEI where a protected device is installed. First of all, for all possible configurations of each type of PEI, and for situations corresponding to the minimum and maximum current magnitudes. Now, the main thing to consider here is the fact that if you've got, say, batteries, solar panels, and a grid connection, what types of supply have you actually got? Because if you're connected to the grid only, then you're going to have a fairly traditional arrangement of, say, circuit breakers, RCDs, and whatever else. All that's coming in from the grid. You just disconnect that if there's some kind of fault. But if you then switched over to running from your batteries, that is a totally different kind of supply, and where that actually is coming into your system isn't going to be the same point as where the electricity from your grid connection comes in. So the location of protected devices has to be considered, because protected devices that are good for one type of thing may not be suitable for another. So you may have to put in additional devices, say to cover when you're running from your batteries or via an inverter. And the same applies to things like solar panels. And the other things to consider are, if you're then running from your batteries and inverter, what kind of characteristics of supply has that got? Not going to be anything like the grid at all. Grid supply is typically going to be high current availability. If you short-circuit out, you're going to have a very high fault current. But if you have an inverter, its actual short-circuit current could be incredibly low. In fact, so low that it may not actually cause things like circuit breakers to trip. So again, you may need to think about different types of protective device or different ratings of them, and again, putting them in different places. Absolutely essential to consider all of the different operating modes, where the electricity is actually coming from and where it's going to, making sure that your protective devices of any kind are actually in appropriate locations and they are actually going to work if faults occur in one or more of these various operating modes. Just have a quick look at this particular example here. This is an example of selectivity with various power supplies. So at the top here, we've got one, which is our public network or our grid connection coming in, and we've got here an overcurrent protection device. However, we've got within the installation these three things here. So two here is power supply, so that could be your solar panels. And again, we need some kind of overcurrent protection device here as well. Then we've got our batteries here, which is the storage units, it says there. And again, we're going to need some kind of overcurrent protection device here as well. And then 3 is our loads, as in what's in the installation. And again, we may need another one, actually, overcurrent protection device here as well, because you can have the actual energy flow can be in many, many different directions here. So you've got to cover basically all scenarios to ensure that if a fault does occur, you can't necessarily assume that it's coming in from here. It may be coming in here or from here, or it could be going in from here and out of here. So all of these different combinations. And as it says at the bottom here, you also need to consider selectivity. So you have two, say here and there. So if it's, say, coming up here from your solar panels going into your batteries, you want to have selectivity so that the most appropriate device is actually going to disconnect. So that if a fault occurs on one piece of equipment, you don't want something else to be disconnected instead. Say a fault occurred on your cabling between your solar panels here, you don't want the batteries to be disconnected, because obviously that's still going to leave the fault open with the energy coming from your solar panels. So we're not going to cover this in any detail here, but just something to consider is that once you start introducing batteries, storage, solar panels, all the rest of this stuff, it's a lot more complex in terms of where the current is actually going and which direction the energy is going in. And again, things like fault current levels and impedance of the supply and all of those things which are often taken for granted. Now, if you actually get BS7671, this particular one, you'll see they've got these annexes here which cover the objectives and concepts, operating modes, interaction with the public network, and the architecture of a Prosumers Electrical Installation. So we're not going to cover those in this video because that could be a whole series on its own, but those really are the things to actually read, and it covers the various things which you really need to consider. And even if you're not going to be installing any of this stuff, or you say, well, we're not going to get on the roof and install solar panels, the reality is that these things are becoming more and more common. So it's pretty much inevitable that you're going to go to a property at some time which will have some or even all of these things installed. And even if you're going there to do some unrelated thing, say to extend an existing circuit or something else, you still need to consider the implications of all of this stuff existing, because say it will affect how the system operates in general, particularly when you're in things like island mode and running from battery storage. So that was part 8, and that is entirely new, so we may do some other videos on that in the future. If you want those, then do comment on that in the description. But that's it for this video. Until next time, thanks for watching.